Hello everyone, Mr. Hissner here, and today we're going to continue on with our chapter on logic. And this is just another step in conditional statements. So we looked at conditional statements, converse, inverse, contrapositive, and now what we're going to do is look at something that's called deductive reasoning. So we're going to take it one step further. We're going to figure out how can we, given a hypothesis and a conclusion, a conditional statement, how can we confirm that the conclusion is true? And it's actually super easy to do. I think that students' biggest problem with this is that they kind of overthink it. So just don't do that. So let's take a look. Well, the first thing we are going to look at is what is called deductive reasoning. Now, deductive reasoning, this is the process. This is the process of reasoning logically and drawing conclusions given facts and statements. And that last part, the statements, we've been looking at statements now for several days, and so that's really what we're going to be looking at to see if these statements are factual. And the first way to use deductive reasoning is the law of detachment. And these are conditional statements. The thing about these is that when the hypothesis is true, when the hypothesis is true, then the conclusion is true as well. Then the conclusion is also true, right? But if the hypothesis is false, it doesn't necessarily mean that the conclusion is false. And we will look at that as well. So what this looks like. We would say if P, then Q, right? That's a conditional statement. P is true. So let's say this is what we're given, and then we can conclude. Thus, Q is true. And again, this is kind of obvious, but it might get a little bit, strange. Anyway, let's just take a look. Otherwise, if you're just looking in terms of P's and Q's, it's very watered down. Let's take a look at our first example and just try to use some of our skills. It says if Mark saves $30, then he can buy a new video game. So this is if P, then Q. So P happens. Okay, so P is true. Mark saved $30. Now, what can we conclude? We can conclude that now Mark can buy video games. And again, like I said, don't overthink it. If Mark saves $30, then he can buy a video game. Guess what? He saved $30. So now he can buy a game. That's it. That's all. Let's look at this one here. So it says if you are 18 years old, if you are 18, then Q, then you can register to vote. Olivia is not 18. So is P true, right? Well, no, she's not 18. Right? She's not 18. So P did not happen. P did not happen. So there's no conclusion. We can't conclude anything about it. We can't conclude that she didn't register to vote, right? Because that would be if not P, then not Q. We can't conclude that, not from the law of detachment. The law of detachment only says that when P happens, Q happens. If P doesn't happen, we don't know about Q. Not from the law of detachment. And let's just look at one more. If you plan to attend prom, then you must purchase a ticket. If you plan to attend prom, then you must purchase a ticket. So this is if P, then Q. Well, let's see. Sarah purchases a ticket. Wait a second. That's Q. We don't have anything that says P is true or Q is true. Then P is Q. Then P is true. This is backwards. This is backwards. This is also no conclusion. No conclusion. Because the law of detachment, it's a law. It works in one way. It's P is true, Q is true. It's a conclusion based on the true value of P, and that's the condition of which we then look at onto Q. So don't make it harder than it is. Don't try to confuse yourself. It's very straightforward. If it's not given to you in the exact measure, then there's no conclusion. Thanks for watching.